Now that the structure has been built, it is time to begin greenhouse production. Types of production include ground or in-soil culture, bag or container culture, and hydroponic systems. Ground or in-soil culture is potentially the easiest and most cost-efficient system. However, the soil should be tested and sterilized to prevent damage from nematode or soil disease infestations. Before planting, the soil should be prepared and raised beds should be made. Finally, plastic mulch should be placed over the beds for disease and weed control. In areas where existing soil is not suitable for farming, containers such as bags, pots, or troughs may be used. A growing medium must be carefully mixed to provide an optimal physical growing environment for the plants. Usually, the growing medium does not provide many nutrients, but it does act as a buffer to nutrient imbalances. In bag or trough culture, the fate of the leachate, or water runoff, is important. In some production areas, laws dictate that leachate must be collected so that it does not pollute the environment. Hydroponic systems can be used by experienced farmers to grow plants free of soil. Plants can be grown in rocks, coconut fiber, or nutrient film systems where the plants are grown bare-rooted in gently sloped tubes down which the oxygen-rich nutrient solution runs. In nutrient film systems, the size of tubes and rate of flow, normally around 1 liter per minute per station, must be sufficient for plant needs at all phases of growth. Key management factors for nutrient film systems include proper aeration and temperature control of the solution. Solution temperatures affect aeration and root respiration. Due to the fact that the nutrient solution passes by all the plants, diseases such as pythium, which causes damping of roots and stem root rots, can be a very big problem. The components of a drip irrigation system include tanks to hold water and nutrient mixes, an electric or gas water pump, filters, valves, pipes, drip lines, emitters, and microtube emitters. It is recommended to have 2 drip lines per row of plants. The greenhouse should be divided into 2 separate irrigation areas for greater control. Optimum water pressure and the distance between emitters will depend on crop, design, and the size of the drip system. The objective is to design an irrigation system that ensures optimal root growth and function. The key is that the water is delivered to the entire rooting zone in a manner that doesn't lead to periods of localized flooding or scarcity in the soil profile. For in-soil culture, rhizotrons, or covered holes dug within the rows of growing plants, show what is happening in the rooting zone of the beds. The wetted area of soil underneath an emitter, or the water bulb, should cover as much of the bed as possible. Water and nutrients will be carried into this area, stimulating root growth. Refer to Fintrac manuals and bulletins for further information on calculating and installing drip irrigation in greenhouses. The water to be used in the greenhouse should be tested during site selection, and then at least 3 times a year for water quality fluctuations. The quality of the water is important, as it influences the design of the drip system, and both the nutritional and maintenance programs. Tests will check for salts and salinity, alkalinity, pH, macronutrients, micronutrients, bacteria, and plant pathogens. Drip lines and emitters should be checked daily for major problems and monthly for emitter performance. Water pressure should be checked every 2 weeks, both before and after the filter.